Welcome back to our channel Sankalp Study Success. Today in this video we are going to learn about what is binomial distribution, and also we are going to solve some of the important problems of binomial distribution. So coming to the binomial distribution, here random variable x has binomial distribution if it assumes only non-negative values, and its probability function it is given by p of x is equals to r, where it is NCR p to the power of r and q power n minus r. This is the formula of binomial distribution, where p is nothing but it is the probability of success and q is nothing but it is probability of failure. That means we can say that p plus q is equals to 1. That means what? Q is equals to 1 minus p from here. So these are nothing but about p and q. So the formula of binomial distribution is NCR p to the power of r and q power n minus r. So the probability of r is equals to 0, 1, 2, 3 and so on up to n. Success is given by q power n, or NC1 p power 1 q power n minus 1. That means what? We are substituting the r values from 0, 1, 2, 3 and so on up to n. Then you will get these expansions. So now the probability of number of successes obtained are called binomial probability distribution, because these probabilities are successive terms. That means you will get it of the binomial expansion. All these expansions you can write it as q plus p whole to the power of n, which is also similar to q power n comma nc1 p q power n minus 1 nc2 p square q power n minus 2 and so on. So you can write it in the simplest form as q plus p whole to the power of n. Now the binomial distribution contains two independent constants. Those are nothing but n and p. N and p are independent constants. Why are we not saying q as independent constant? Is if you know the value of p, then you can find the value of q from 1 minus p. That means value of q is dependent upon value of p. So that's the reason n and p are the independent constants here. Now n is also called as degree of binomial distribution. See here, q plus p whole to the power of n. N is nothing but here it is the degree of binomial distribution. This is completely the binomial distribution, that is binomial expansion. Then to this binomial expansion we are having the degree as n. So we can say that n is also called degree of binomial distribution. So now coming to the next one, what is probability mass function? Here probability mass function of binomial distribution should satisfy these two conditions. Let us see what are those conditions. Here f of r should lie between 0 and 1, and summation of r is equal to 0 to n. NCR q power n minus r and p power r should be equal to 1. That means what? This is nothing but the binomial expansion formula, right? So this should be equal to 1. Then you can say that it is the probability mass function. Now let us see what is cumulative distribution. Cumulative distribution of binomial distribution is given by summation x equal to 0 to n ncx p power x and q power n minus x. So you have to remember all these formulas. Now binomial distribution can also be written as, you can also write it as b of x n comma p. That means what? Here it is nothing but ncx p power x q power n minus x. You can also denote it in this way, binomial distribution. So this is about binomial distribution, probability mass function and also cumulative distribution. Now let us see what are the conditions to apply binomial distribution. See here, there are few conditions. There are only two possible outcomes for each trial, that is success and failure. See, we said that p is the probability of success and q is the probability of failure. That means there are only two outcomes of binomial distribution. One is the success and the other is the failure. Now, trials are repeated under identical conditions for a fixed number of times, say n times. That means you take the example of tossing a coin. If you toss a coin for one time, That means you are tossing a coin for the one time, then our outcomes may be either head or tail. If in the same case, if you are tossing the coin for the 2 times, or you are tossing the same coin for the 3 times, that means you are conducting the experiment in the identical conditions only. That means you are repeating the experiment under identical conditions only. So here that says that trials are repeated under identical conditions for fixed number of times, say n times. Now, the probability of success in each trial will be same. See, if you are tossing a coin for the one time, then the probability of getting head will be 1 by 2 and the probability of getting tail will be also 1 by 2. That means probability of success and probability of failure will be always same for each trial. Now, the trials are independent. That is, probability of an event in a trial is not affected by the result of any other trial. If you are trying for the once, that means let us take the same example of tossing a coin. You are tossing a coin for the first time and you got one probability. Then if you toss the coin for the second time, then you will get another probability, such a way that the first probability will not affect the second probability. So these are the conditions, 4 conditions which we have, where whenever you need to apply binomial distribution, you have to follow these rules. Now let us see what is mean of binomial distribution, and also we will see what is the variance of binomial distribution. Here, coming to the mean of binomial distribution, we are proving what is the mean of binomial distribution here. We know that E of x is equals to summation of xi pi. This is the mean. Okay, we know this E of x is equal to summation of xi and pi. Now you can write it as summation of x is equal to 0 to n x into p of x, correct? Because E of x is nothing but x into p of x. Now p of x is nothing but the equation of binomial distribution, which is ncx p power x q power n minus x, correct? So let us substitute ncx p power x and q power n minus x. So this is the value. Now we can write ncx as n factorial by x factorial into n minus x factorial. So here we have replaced ncx with its value. Now x factorial can be written as x into x minus 1 factorial, correct? So here x and x will be getting cancelled, and you can also write n factorial as n into n minus 1 factorial. So that here n and here p both are constants, so you can take it outside. So here np into summation of x equal to 0 to n, and the remaining term you will write as it is, that is n minus 1 factorial p power x minus 1 q power n minus x divided by x minus 1 factorial into n minus x factorial. Now in order to simplify this expression, we are substituting y in place of x minus 1. So let us substitute y is equals to x minus 1. From here you will get it as x is equals to y plus 1, right? So x is equals to y plus 1. So now if you substitute x is equals to 1, then you will get y value as 0, right? Because 1 minus 1 is 0. Now if you substitute x value as n, then you will get y value as n minus 1. So here what happens is, now let us substitute the x value here and also x minus 1 as y here. Now see, np into summation of y is equals to 0 to n minus 1. Why did we find out this? Because the limits will be changed. Here x is equal to 0 to n, then here y will become 0 to n minus 1. Now if you substitute x minus 1 as y, then you will get it as n minus 1 factorial p power y and q power n minus y minus 1 divided by x. Again we can substitute as y plus 1, right? X is nothing but y plus 1. So n minus y minus 1 factorial in place of n minus x factorial, and x minus 1 factorial we are substituting it as y factorial. So from here you can say that it is of the form q plus p whole power n minus 1. So we know that p plus q is equals to 1, right? Because probability of success plus probability of failure is equals to 1. So if you substitute 1, you will get the mean as NP. That means mean of binomial distribution is NP. This is the value. Now let us see what is the variance of binomial distribution. This is the same process which we have done for the mean of binomial distribution, but here the equation of V of x, because here mean is nothing but E of x and here variance is nothing but V of x. So V of x is equal to E of x square minus E of x whole square. So this is the variance formula. Here we know that E of x is equal to NP. Just now we found what is the mean of binomial distribution. It is NP. So we can substitute NP whole square. But in the place of E of x square, now we have to find out. E of x square is nothing but summation of x equal to 0 to n x square into P of x. Okay, this is the value of E of x square. Now x square can be written as x into x minus 1 plus x, right? Because if you expand it again, x square minus x plus x, where these both will be getting cancelled and you will be remained with x square. So you can write it as x square is equals to x into x minus 1 plus x. So here, now after substituting, we are just multiplying with the P of x into x minus 1 into P of x plus summation of x into P of x. So now P of x can be written as NCx P power x Q power n minus x. And here x into P of x, it is nothing but NP because it is the mean. We have just found mean is NP. So we are substituting in the place of x into P of x. So here NCx will be written as n factorial by n minus x factorial into x factorial. So here you can simplify by taking x into x minus 1. We are writing n factorial as n into n minus 1 into n minus 2 factorial, and also you are writing x factorial as x into x minus 1 into x minus 2, because here x and here x will be cancelled, x minus 1 and x minus 1 will be getting cancelled. So you will be remained with n into n minus 1 and also p square. These are the constants, so you can take it outside, n into n minus 1 into p square, and you are left with the remaining expression, which is the same thing which we are writing. Now in order to simplify this equation, you have to take x minus 2 as y. Okay, now if you substitute x minus 2 as y, then x value will be y plus 2. So here if you find out the limits from x is equal to 2 to n, you will get it as y is equal to 0 to n minus 2, which is the same process which we have done for the mean of binomial distribution. So here after substituting, we will get n into n minus 1 into p square of, this is of the form p plus q whole power n minus 2, and we also know that value of p plus q is equal to 1. So if you substitute 1 here, it becomes 1. So n into n minus 1 p square plus np. We got n into n minus 1 of p square plus np. So if you expand it, you will get it as n square p square. Let us expand here. This is n square p square minus np square plus np. So this is the value of E of x square. So now if you substitute V of x is equals to, we know that E of x square minus E of x whole square, right? So E of x square is nothing but n square p square minus np square plus np minus np whole square, that is nothing but n square p square, which is E of x whole square. Now n square p square and minus n square p square will be cancelled, and you will be remained with np minus np square. So if you take np as common, you will be remained with 1 minus p. 1 minus p is nothing but q, right? Because p plus q is equal to 1, and here from here q is equals to 1 minus p. So NPQ. So this is nothing but the variance of binomial distribution. Variance of binomial distribution is NPQ. So in the same way, this is the variance. In order to find out standard deviation, which is nothing but sigma, that is equal to square root of NPQ, because it is the square root of variance. So we have found mean is equals to NP, variance V of x is equal to NPQ, and standard deviation sigma is equal to square root of NPQ. These are the most important formulas which we are going to use in our problems to solve binomial distribution. So here, coming to the next topic, it is recurrence relation for binomial distribution. We know that P of x is equal to NCx p power x q power n minus x, which is nothing but the expansion of binomial distribution. If you take x value as x plus 1 and if you write the second expansion, it will be NCx plus 1 p power x plus 1 q power n minus x minus 1. This is the second equation. Now if you divide equation 2 with equation 1, that is p of x plus 1 by p of x, then by further simplification, you will get the value of recurrence relation as n minus x by x plus 1 into p by q. This is the recurrence relation. You have to remember this formula in order to you will get it only for the 1 mark question. Maximum we are not going to get this recurrence relation for the long answers. So this is the formula of recurrence relation of binomial distribution. So now let us solve some of the problems related to binomial distribution. Here the question is, if 8 coins are thrown simultaneously, then find the probability of getting 6 heads is the first one. So let us solve it one by one. Here it is given that total number of coins is equal to 8. That means n value is 8. If you are tossing a coin, that means 8 coins are thrown simultaneously. That means for each coin the probability of success is 1 by 2 and the probability of failure is also equal to 1 by 2. So p and q values are 1 by 2. Now first one, which is probability of getting 6 heads, right? That means probability of x is equal to 6, right? That means what? NC6 p power NCR p power r and q power n minus r, correct? We are having that n value as 8. So 8c6 p power 6 q power 8 minus 6. That means by substituting p and q values, half power 6 and half power 8 minus 6 is nothing but 2. So if you substitute all these values and if you simplify, then you will get the value as 0.109. So this is the value of, if you toss 8 coins simultaneously, then the probability of getting 6 heads is 0.109. Now let us see what is the probability of getting 5 heads and 3 tails. Here, that means what? It is nothing but the probability of getting 5 heads. If you get 5 heads, the remaining will be exactly, if you get 5 heads, then the remaining will be 3 tails, right? That means probability of x is equals to 5, right? Then you can write it as NC5 p power 5 and q power n minus 5. So now if you substitute n value and pq values, then you will get it as 8c5 half power 5 and half power 8 minus 5, which is nothing but 3. That means if you simplify this value, then you will get it as 0.218. This is the probability of getting 5 heads and 3 tails. Now let us solve the third question, which is at least 5 heads. That means what? Till now it was exactly 6 heads, exactly 5 heads. But it is given that it is at least 5. That means it may be 5, 6, 7 or 8. That means from 5 to 8 you may get any number of heads. So let us solve this problem, third one, which is exactly 5. Sorry, not exactly 5. It is at least 5. That means p of x greater than or equal to 5, right? So how can we write p of x greater than or equal to 5? Which is p of x is equal to 5 plus x is equal to 6 plus x is equal to 7 and x is equals to 8. So if you find the probability, sum of the probabilities of all these, then you will get the at least 5 heads. Okay, because at least 5 means you may get 5, you may get 6, you may get 7 or you may get 8. So if you sum up all these, then you will get the probability of x greater than or equals to 5. So now by substituting in this 8c5 half power 5 and half power 8 minus 5 is nothing but 3 plus 8c6 1 by 2 8c6, 1 by 2 whole power 6 and 1 by 2 whole square, less 8c7, 1 by 2 whole power 7 and 1 by 2 whole power 1, plus 8c8, 1 by 2 whole power 8 and 1 by 2 whole power 0. That means now if you solve each and everything and if you add, then you will get the value as 0.36. This is nothing but at least 5 heads. You will get the probability of at least 5 heads. Now coming to the next question, he is asking that the probability of getting at most 3 heads. That means what? You may get at most 3 heads means it is less than or equal to 3. That means you may get 0, you may get 1, you may get 2 or you may get 3. That is nothing but at most 3 heads. So let us see here, P of x is less than or equal to 3. That means x is equals to 0, P of x is equals to 1 plus P of x is equal to 2 plus P of x is equals to 3. So now, you have to find out all these values, and if you add, then you will get the probability of getting at most 3 heads. So let us solve it. 8c0, half power 0 and half power 8 plus 8c1, 1 by 2 whole power 1 and 1 by 2 whole power 7 plus 8c2, 1 by 2 whole square and 1 by 2 whole power 6 plus 8c3, 1 by 2 whole power 3 and 1 by 2 whole power 5. So now if you add all these values, then you will get it as 0.36 again. So here, this is the probability of getting at most 3 heads. So in this way, you have to solve the problems by taking the binomial distribution. So now let us see the second question. It is the probability of man hitting a target is 1 by 2. That means the probability is 1 by 2 means P is equals to 1 by 2. Then Q becomes 1 minus 1 by 2, which is again 1 by 2, right? So we have given with P and Q. And he fires 6 times. That means what? N is equals to 6. We are given with N value also. Then now we have to find out the probability that he hits the target exactly 2 times. That means the first question, exactly 2 times. That means it is nothing but probability of x is equals to 2, correct? Which is exactly, that means we are taking equal to 2. Now, NC2, P power 2 and Q power n minus 2 is the formula. Now by substituting all N, P and Q values, then we'll get it as 6C2, half power 2 and half power 6 minus 2, which is nothing but 4. So here, if you solve this problem, then you will get it as 0.23. This is exactly 2 times. Now, let us solve the second question, which is more than 4 times. That means what? Let us solve it. More than 4 times. That means P of x is greater than 4, correct? More than 4. He didn't say that it is at least 4. If it is at least 4, then we will also include 4 that is greater than or equal to 4. Here it says that only more than 4. That means P of x is greater than 4. So here P of x is equals to 5 plus P of x is equal to 6. That's it. Because it is only n value is only 6 and greater than 4 are only 5 and 6. So probability of 5 plus probability of 6. Now let us find out the value here. 6c5 half power 5 and half power 1 plus 6c6 1 by 2 whole power 6 into 1 by 2 whole power 0. So this is the value. Now if you add these values, then you will get it as 0.109. This is the probability of hitting the target more than 4 times. Now let us find third one. That probability of hitting the target at least 1 time. That means what? At least 1 time means it is greater than or equal to 1. That is third one, at least 1 time. Probability of x greater than or equal to 1. That means you have to add probability of x equal to 1 plus probability of 2 plus and so on. You have to add up to probability of 6. So that means which is also equal to 1 minus probability of 0, right? Because here from 0 to 6, we are adding all the values from 1 to 6 except 0. If you remove 0 from 1, because the sum of the probabilities will be equal to 1, right? So 1 minus probability of x equal to 0 will also be equal to probability of x greater than or equal to 1, right here. So let us find this probability of x equal to 0. That means 6c0, half power 0 and half power 6. That means if you solve this problem, then you will get the value as 0.984. This is the value which you get. That means this is the probability of getting at least one time. So in this way you have to solve the problems. So now let us go into this third problem, which is 2 dice are thrown 5 times. That means experiment of tossing a coin is done 5 times. That means n is equals to 5, right? If it is a dice, then probability of getting sum is equal to 7. Sum is 7. That means what? You will get sum as 7, which is only for 6 comma 1. Correct? So now probability of sum is 7 will be only 1 by 6, and probability of failure will be obviously equal to 1 minus 1 by 6. That is nothing but 5 by 6. Correct? So sorry, it is not 5 by 2, it is 5 by 6. So now what is he asking to find out is, you have to find the probability of getting sum 7 at least once. That means what? The first one is probability of x at least once means greater than or equal to 1. Correct? That means you can write it as 1 minus probability of x equal to 0, because previously we have done the same problem, right? So that means what? 1 minus nc0, that means 5c0, and p is nothing but 1 by 6 whole power 0 and 5 by 6 whole power 5. So if you solve this problem, then you will get the answer as 0.598. So just you have to remember the formula and you substitute the values in the given formula so that you can easily find out the value. So now coming to the second one, what is the probability of getting sum 7 2 times? That means exactly 2 times. P of x is equals to 2. Let us find the value. Now 5c2, 1 by 6 whole power 2, 5 by 6 whole power 5 minus 2, that means it is 3. If you solve this value, then you will get it as 0.1607. So this is the value which we get for the probability of getting exactly twice, that means 2 times. Now he is asking the probability from between 1 to 5. That means what? Third one, probability of 1 less than x less than 5. That means probability of 2 plus probability of 3 plus probability of 4. Because 1 and 5 are excluded, they are not included. So if you solve this, nc2, what is n? Which is 5 times 5c2, 1 by 6 whole power 2, 5 by 6 whole cube, plus 5c3, 1 by 6 whole power 3 and 5 by 6 whole square, plus 5c4, 1 by 6 whole power 4, 5 by 6 whole power 1. Now if you solve this equation, then you will get the value as 0.1961. So all the problems which we are solving are of the similar model. So just we need to remember the formula, and if you substitute the values according to the given question, then we will get the answers. Now let us see the next question, which is find the standard deviation for mean is equals to 4. Mean equals to 4 is given. That means what? NP is equals to 4. And here variance is equals to 3. That means formula of variance is nothing but NPQ, that is equals to 3. And he is just asking to find out the standard deviation. Standard deviation is nothing but square root of the variance, right? Square root of the variance. So variance is nothing but NPQ. Square root of NPQ. What is the value of NPQ? Which is 3. Square root of 3 is nothing but the standard deviation. So in this way you can find out the standard deviation from the variance. So this may be the 1 mark question which can be asked. So that's the reason we have solved it now. Now let us go into the next question, which is Find the probability that the life of a bulb 100 days is 0.05. That means what? Probability is 0.05. Life is up to 0.05. Then what will be Q? 1 minus 0.05, which is nothing but 0.95. This is the probability of failure. This is the probability of success. We are having P and Q values. Now, find the probability out of 6 bulbs. That means N value is 6, right? So, out of 6 bulbs, at least one. Probability of at least one. He is asking the probability of at least one. That means P of x greater than or is equal to 1. So, P of x greater than or equal to 1, which is nothing but 1 minus probability of x is equal to 0, right? We have already solved this kind of problem. That means 1 minus 6C0, 0.05 whole power 0 and 0.95 whole to the power of 6. That means we are just substituting all the values N, P and Q values in the given formula. Then we will get the answer as 0.264. So the probability of out of 6 bulbs, at least one bulb, the probability of just at least one bulb is 0.264. Now we need to find out the probability of bulbs greater than 4. How do we find out greater than 4? Total number of bulbs are 6. Greater than 4 means probability of 5 plus probability of 6, right? So let us find out probability of x not greater than 6, it is greater than 4. So you can find out the probability of 5 plus probability of 6, which is equal to probability of 5 plus probability of 6. Now let us substitute the values here, which is N is nothing but 6, 6C5, 0.05 whole power 5 and 0.95 whole power 1 plus 6C6, 0.05 whole power 6 into 0.95 whole power 0. So now by simplifying this problem, we will get the answer as 1.79 into 10 to the power of minus 6 is the value which we get. So now coming to the third one, which is none. None will be having life of 100 days. That means what? It is nothing but probability of x equal to 0, right? Probability of x is equals to 0. That means 6C0, 0.05 whole power 0, 0.95 whole to the power of 6. Then you will get the value as 0.735. That means the probability out of 6 bulbs, none will be having life of 100 days is the value is 0.735. So in this way you have to remember all the formulas, and if you substitute in the given equation according to the question, then you will get the answers very easily. So thank you for watching the video. Let's meet in the next video.